Morning chemistry students. Today we're going to be learning about a special topic in stoichiometry called percent yield. So far with stoichiometry, we've learned how to do a lot of things. We've learned how to calculate how many grams or moles of one substance relate to how many grams or moles of another substance. A couple of example problems. We can, at this point, calculate how many grams of hydrogen are needed to make 18 grams of water, or how many moles of sodium are needed to make 58 grams of sodium chloride, or how many moles of magnesium sulfate could be made from 25 moles of magnesium. Stoichiometry is usually, when we use it in industry, it's usually about making a product. And frequently, we know what we expect to get from our product. We know how much product we expect to get from our starting materials, but sometimes we don't get the amount of product that we are expecting to, and it's due to experimental errors usually. So measuring less precisely than we should, or maybe we didn't wait long enough for the reaction to complete, or whatever. So we want to find out what percent we got of what we should have theoretically gotten. So here's a sample problem, and I'll show you how to work this one out in just a minute. What is the percent yield if 18.7 grams of H2 are produced from 396 grams of calcium in the reaction below? So for this question, we know how much product we actually got, but the question is how many grams of hydrogen should we get if everything works perfectly? So what we really need to do here is take our 396 grams of calcium and figure out how many grams of hydrogen we should get. So to find percent yield, you're going to take what we call the actual yield, so that's going to be given in the question, and divide it by the theoretical yield, which is what we typically will calculate, and then multiply by 100. Now sometimes a question will give you the actual yield and the theoretical yield, and so all you have to do is divide and multiply by 100. But sometimes the theoretical yield has to be calculated. So the actual yield always will be given to you in the problem. So they're going to say something like they got X grams, or this number of grams was recovered or obtained. Theoretical yield is often not given, and you have to calculate it. This is a situation where two numbers might be found in the question. One might be the actual yield, and one might be either the theoretical yield or used to find the theoretical yield. I will tell you the actual yield and the theoretical yield have to have the same unit and substance associated with them. So going back here, the percent yield is what we're looking for, and it says 18.7 grams of H2 are produced. So this is our actual yield, and our theoretical yield is going to have units grams of H2 also. So I'll show you how to do this one here in a second. So this is the formula that you need to write down. Maybe memorize actual yield over theoretical yield times 100 is percent yield. So I'm going to work this problem out on the board. Let's pull it back up here, and we'll do that in just a second. Okay, for this problem, we're going to start by, of course, always balancing the equation. So we've got CaH, Cl, 1, and so we're going to balance chlorine first probably, so we'll put a 2 here, and that balances our equation. So always start by balancing your equation. The next thing we're going to do is say, okay, 18.7 grams of hydrogen was obtained. This is what we got, so that's our actual yield. So we're going to save that for doing our percent yield calculation in a minute. In fact, I'll write that over here. Percent equals 18.7 grams of H2 divided by the theoretical yield times 100. So this theoretical is what we need to find out. And we know that it needs to end in grams of H2 because these two, actual yield and theoretical yield, must have the same unit and the same substance. So the question really becomes, how many grams of hydrogen should we have gotten, assuming we started with 396 grams of calcium? So we really want to know how many grams is our theoretical yield. So for this question, we're going from grams of calcium to grams of hydrogen. Grams to grams means 4 fractions. So we start with 396 grams of calcium over 1. And then we're going to go grams to moles of that substance to moles of the other substance that we're looking for to grams of what we're looking for. And of course our units have to cancel. So here are all the units written in, and now we have to figure out what numbers go in each of these boxes. So we know when we're going between grams and moles, the moles is 1, and the grams comes from the periodic table. So calcium, I've got my periodic table here, is 40.08. Of course, you might be using a slightly different periodic table with slightly different numbers, and that's fine. So now we've got grams of calcium canceling. Now we have moles of calcium, and moles of calcium will cancel here. If we're going moles to moles, then we don't use the periodic table. We use our coefficients. So we're going to take the coefficient for calcium, 1, and the coefficient for hydrogen, 1. And then we can cancel moles of calcium. Now we have moles of hydrogen. And moles of hydrogen will cancel here, and we're going moles to grams. So we're going to be doing 1.008 for hydrogen, but we multiply it by 2 because it's H2. So this will be 2.016. So again, the grams comes from the periodic table, the moles is going to be 1. And now we have a unit, grams of hydrogen. And remember we said this theoretical yield needs to be grams of hydrogen. So we should be good here. So let's do the calculation. Where did my calculator run off to? Here we go. So we're doing 396 times 2.016. We'll divide that by 40.08. And we get 19.9 grams of H2. And I know my unit's going to be the same as this unit left, right? So 19.9 grams of hydrogen is how much hydrogen we should get, assuming the reaction goes perfectly and we measured perfectly and everything works great. So 19.9 grams is our theoretical yield. Our actual yield was 18.7. We didn't quite get every molecule to react the way it was supposed to, so we're going to have to take our actual yield divided by our theoretical times 100. So 18.7 divided by 19.9 times 100 is 93.9. Actually, probably 94.0 because that's 93.96 is what I got. So that is our percent yield. So I'll do one more problem and then I'll cut you loose on your own to solve some problems on your own. Okay, so for the second problem we're going to do here, we have this reaction, and the question says if we start with a 1.34 grams of iron 3 oxide, that's Fe2O3, and we produce 0.83 grams of iron, what's our percent yield? So we know we're going to use this equation. Percent equals actual over theoretical times 100. And we know the actual yield is always given in the reaction, or in the question. So the actual yield is going to be one of these two numbers, and the other thing is going to be what we use to find the theoretical yield. So the actual yield has to refer to a product. So this number up here, 0.83 grams of iron, that's going to be our actual yield. So we're going to say our percent is 0.83 grams of Fe over a theoretical yield, which will be grams of Fe, times 100. So now we have to figure out how many grams of iron should we produce. We know this is how much we did produce, but how many should we produce based on the starting material? And again, because we need grams of Fe, this is what we need. And we're starting with grams and we're going to grams, we know we're looking at 4 fractions. Again, grams to moles to moles to grams. So, where are out my black markers here? So we're going to start with this. We're going to go to grams of Fe. We're starting with 1.34 grams Fe2O3. That's going to be a 1. We know we're going grams of this substance to moles of the same substance, to moles of our new substance, to grams of our new substance. And then we can fill in our bottom units by making sure that the units will cancel. This one goes here. And then we look at each fraction to find the numbers. We know that 1 mole of Fe2O3 will be some number of grams of Fe2O3. So I'm going to write some stuff down here. So the Fe is going to be 2 because of the 2 subscript. 2 times 55.85. And we're also going to have, let's put this down here, 3 times oxygen's mass, which is 16. And we're going to add those together. 55.85 times 2 plus the quantity, 3 times 16, closing parentheses, 159.7. Then we come to this fraction. We have moles over moles. When we're looking at how moles compare with other moles, we look at our coefficients of our balanced equation. And guess what I forgot to do? I didn't balance the equation, so we can't solve this problem yet. So let's get on that. So we have 2 iron, so I'll start maybe with a 2 here. We have 3 oxygen, so we need a 3 here. And we have 3 zinc. Is that balanced? 3 zinc, 2 iron, 3 oxygen, 3 oxygen. Okay, now we're balanced. So in our mole to mole ratio for Fe2O3, there's no coefficient, so that's a 1. And for Fe, that's a 2. And then for our last one, we're going to say grams to moles, grams and moles, it's always 1 for the moles. And the grams comes from the periodic table, 55.85. So now if our units cancel and we have the right unit at the end, then we should be good. So grams Fe2O3, grams Fe2O3, moles, moles, moles of iron, moles of iron. We have grams of iron left. Is that what we want to put here? Yes. These two have to have the same unit. So now we're going to do our math here. 1.34 times 2 times 55.85 divided by 1 times 1 times 1 times 159.7. I think I might have miscalculated that. Let's try that again. Got a huge number. Divided by 159.7, that makes more sense. So I got 1.07 And so over here, we're going to plug that in. We should have gotten 1.07 grams of Fe, but we only got 0.83 grams of Fe. So we didn't get as much as we should have. Now keep in mind, your theoretical yield is almost always going to be bigger than your actual yield because you can't create more of a product than you expect to. You can sometimes end up with contaminants in your product, and so sometimes that number will be higher, but usually not. So our last step then is to calculate the percent yield. So 0.83 divided by 1.07 times 100, 77.6. And that gets the unit percent, and you don't actually need a substance on this one. It's one of the few numbers in stoichiometry where you would not need the substance. Okay, so that's it. I will be in the WebEx. Stop by and visit if you have any questions. And you should have a check for understanding to take here.